In my previous demonstration, we spoke about agent interaction patterns, and we spoke about these three patterns, and then saw a demonstration of this, basically this demonstration of this supervisor pattern, right? Where the supervisor decides based on the activity which follower agent to call, right? So if I say add 5 and 2, we saw how supervisor called multiplication. If I say multiply 10 by 5, then the supervisor called multiplication. Sorry, it is flip-flopped. So this is addition and this is multiplication, right? And then this was the demonstration that I did earlier. The demonstration that I'm going to show now is where you will give both these instructions together. The supervisor will split them up, and one task, it will route it to the multiplication task, it will route it to multiplication agent, and the addition task, it will route it to addition agent. And then the node, the final answer node, once they answer their task, the final answer will consolidate the final answer. This is the demonstration that we are going to see. So basically in this demonstration, the new thing is the parallelly splitting the task and parallelly running these two agents. And then we'll see how the final node takes the input from both agents and give the answer. Let's go to the code and see. So here, so these are the two tools that I created, add and multiply. Then the supervisor agent, this is where I have the change. In the system prompt, I said you are a supervisor tasked with assigning tasks to your workers. Given a task, you first split the task based on the skills your workers possess. Then you map each task to the relevant worker. You have access to the following workers. So here I'll pass this workers because I have multiplication expert and addition expert, right? Please output the workers mapped to the respective task in a JSON format. Here is an example of the output, right? So I gave an example that if your workers are this and the input is like this, like where it is talking about divide by subtract, I'm telling how the output should be, right? I gave a few short example to the supervisor, right? And finally, I am creating the prompt, typing it to the LLM, and then getting the output. This is my supervisor, right? And then in the addition expert is where after the task has been split, right? After I get the output like this, the addition expert, what it is doing is it is extracting the task that is meant for the addition expert node. And this is what I like about LangGraph. Here I am combining non-determinism with deterministic approach, right? And this is the beauty of flow engineering, right? So LangGraph is allowing me to create a or limit the scope of the flow, right? It's like if I would not have LangGraph, right, then the agents would have been all non-deterministic, and you would not have done or you would not know how the steps are following. So I know autonomous agents is trying to do that, but I think it will take some time. But till the time to actually limit the flow, to control the flow, I think I feel like LangGraph is one of the best tools that I have seen so far, right? Where it is controlling the flow of the agents. It's like I actually compare it with a river, right? So a river is actually the flow of the river is controlled by the banks of the river, right? And the river, like if you want it to flow in a different direction, we can actually cut a canal, right? And then flow the water somewhere else, right? Where the water itself, the flow of the water is non-deterministic, but I am bringing some determinism by structuring the flow of the water. It's the same comparison works here. Landgraph is controlling the flow, right? And I think that's why we'll see a lot of usage of Landgraph going forward, as it is able to combine determinism and non-determinism together. Now, coming back to this, right? So additional expert, I'm taking a deterministic approach here, where based on the message, the additional expert actually is getting the message or the task that is, so the task output is like this, right? This is the, so for example, it will be addition, right? An addition task, right? That task is, the addition is taking it. And the system prompt for addition expert is, you are an expert in addition, give two numbers, given two numbers, you add them and return the result, right? And then it is, I gave the addition tools to it, the add tool. And based on the message, it is invoking like through the prompt, it is invoking the tool and then adding the two numbers and returning it back to the state, right? So if you see this shared state that I created is, this is the shared state messages, right? So it is putting it back to the shared state, right? So addition expert, similar to the addition expert, I created the multiplication expert as well. The only difference is here I am deterministically picking up the multiplication expert task, and then multiplication is multiplying the two numbers and again returning it back to the state. It is again updating or adding it to the shared state. And finally, the generate final answer is where it is taking the entire states, because here I said you are responsible to provide the final answer based on the sequence of messages provided to you. The sequence of messages are in my state, which is already updated and added by addition and the multiplication agent and the supervisor agent, right? So here, after I create the agent, then I so invoke, if you see here, I invoke the agent on the entire state, right? Because here I'm saying you're responsible to provide the final answer based on the sequence of messages provided to you, right? And finally, I create the workflow. I add the supervisor node. I create the add the addition expert node, multiplication expert, and the final expert, the final answer node, right? This nodes I create. Now I create an edge between start to supervisor node to addition expert, supervisor node to multiplication expert. And this is where I am combining the output of addition expert and multiplication expert, right? I'm saying like after this two are done, then call the generate final answer, which is the last node to give the consolidated answer, right? Then I compile it. So before we run it, let's actually see how it looks like. So this will look like this. So start, supervisor node, addition expert, multiplication expert, and finally the generate final answer. Now let me comment it out and run this. So here I'm saying, please add 5 and 6 and multiply 5 by 10, right? So there are two tasks. So we'll see, it will split it up now. It is going to split up. Yeah, so addition expert, add 5 and 6, multiplication expert. So the supervisor had split it up, right? This is the split that it did. Addition got add 5 and 6, right? So the addition say the sum of 5 and 6 is 11. Multiplication expert got the multiply by 5, 10, right? Which is 50. And the final content is the sum of 5 and 6 is 11, and the product of 5 and 10 is 50, right? And this is the final answer, right? So which combined this two and gave a final answer. So this is what I wanted to show as part of this demonstration. So what we saw is this pattern here, where the supervisor splits the task, assigns the task simultaneously to multiplication addition agents, do it parallelly. Once they are done, we get the final answer. Thank you.